So for brainstorming, we're going to go with last year's mission as we are waiting to still receive this year's mission from Northrop. So last year's mission, the vehicle will demonstrate the survival of hard landing capability, hiker detection, hiker transportation, and the vehicle will be able to carry the vehicle will be carried by the CPP UAV, which is just an aircraft, to the hiker's vicinity, and then be released during flight and make a safe landing near the hiker's vicinity. It will then navigate to prepare the hiker for transport. After this hiker is properly secured, the vehicle will transport the hiker to an open area where the medvac aircraft can perform a transfer, and the vehicle mission is complete when it goes back to headquarters. So basically, we'll for this mission, we need to be able to safely land, pick up the hiker, navigate the hiker to an area where we will then switch it off to another aircraft, and then we will just head back to the HQ area, which is just in a random vicinity. So that was like the main idea of the mission. And what Northrop usually does is gives us a set of requirements that we need to obtain to. So these requirements go along with our mission. And so the requirements that were given last year was that the vehicle needs to survive that drop from the aircraft. The second one, the vehicle shall be able to drive a 52.7 grade hill at a 3 miles per hour while fully loaded. So it needs to be able to climb up a hill. The vehicle shall have the capability of remote mandate operation through video feed. The vehicle should be able to autonomously navigate to a specific GPS location, and the vehicle shall detect and avoid obstacles such as rocks and trees. The vehicle shall be capable of preparing an immobilized hiker to transport, and the vehicle shall be capable of transporting the hiker 1,500 feet away from the original position. So for this little activity, you guys are going to be set into groups and basically brainstorm kind of design aspects of this vehicle and to see how many requirements you guys can meet. You guys don't need to go specific, like what motor you're going to use to be able to climb up that hill. More of like, so it needs to climb up a hill. What kind of treads does it need? How many wheels does it need? Kind of a more design aspect-y way. And don't be discouraged if you guys don't meet all the requirements. It's just an activity. Just try and hit as many as you can. So for brainstorming, once you guys get into groups and introduce yourselves, what's best is to focus on quantity. So just throwing out random ideas, trying to get as many ideas as possible, and to withhold criticism. So for like the initial brainstorming, nothing is off the table. Just to like get ideas out there, no matter how ridiculous it seems, we'll go back and refine them to see if it's actually feasible towards the end. So like we said, we always welcome wild ideas like a grappling hook. No. And then once you have this abundance of ideas, you would want to see what you can combine and how you could improve on the ideas. So maybe you get a wild idea like a grappling hook. Maybe that's not feasible, but maybe it's feasible to have a little like claw that pulls you up the hill. So that's a typo. And then the fifth one is you just want to narrow down your ideas in order to meet those requirements. So some ways that you can write down your ideas is just through Word. You can type it out, or there's this website called sketch.io. It basically allows you to be able to it just gives you a random area to draw in, so you can express your ideas in that way. So with that, here's a quick schedule overview of the day that's laid out. This presentation's right about to end, and then you'll break into your brainstorming groups, and then we will come together at 11 a.m. where one person out of the group will present your ideas. It doesn't need to be like a PowerPoint or anything. It could just be a list on Word or just the doodle on Sketch.io. It doesn't have to be that long. We just want to make sure that the idea that you can express your idea to the other people that weren't from your group. And then we break for lunch for an hour. And then at 1 p.m., we have a Drive Requirements workshop with the full team. This includes GCS and UAV as well, and systems. So with that, I've broken you guys mostly into teams. If you guys can remember, like find your name to see what number you guys are associated with, and I will open up. But yeah, is there any questions while we wait?
Do you know when we'll get our actual project design requirements?
Kind of in the middle of September, middle to late September. So since we do this project with Cal Poly SLO has not yet started their school since they are a COVID system. So Northrop kind of wants us to start at similar times. So yeah, so middle to late September. So if I'm not mistaken, now you guys should be able to assign yourselves to a breakout room.
Oh, shit.
Yeah, I don't see anything.
Really?
Nope.
Well,
Neither do I.
add rooms, recreate. Okay, so it's not gonna pop up. You need to go down to like where you raise your hand and it has a little symbol for breakout rooms. You click that and then you, nothing? Nothing, Charles?
No, it's normally there. It's not there now.
Jonathan, do you have a question or are you just raising high?
Oh, I'm just doing that. Yeah.
Oh, okay, sorry. Now is it there?
Nope.
Sorry, I forgot to mute.
Good, Evans.
Plus, there might be a button that just says like open breakout rooms, and then that
Okay,
might
now
work.
it should.
Yeah, there we go.
Okay. Thank you guys for dealing with my technical difficulties. I haven't used Zoom through this aspect of. Okay. All right. Well, see you guys in like an hour. I will share my PowerPoint so you guys can review the list.
Hey, can you put the document up that shows which person goes in which room? I
Yeah.
got the color down, but I didn't get the actual group number.
No, that's fine. Sure.
Thanks.
Cool.
Hey Celeste, I don't think I got the part where you're telling us what to do when our name isn't on the group.
Oh yeah, you simply just let me know.
Oh, okay.
Could you go into group 1?
Hey Celeste, I don't think I have a group either.
Okay. Can you go into group 6? Does anyone else need a group?
How do you-
Just having technical difficulties.
Sorry. Sev, I think you're in group 5, if that was your question.
Yeah, I know that. I can't join on mobile.
Oh,
I'm trying to do it on my computer right now, but it's mic's not working. Sorry, I'll be in a sec.
no, that's fine.
Oh, I did it.
How do you join the group again?
Okay, so if you go down to the bottom of kind of where it has like the reactions,
Mhm.
there should be a button, breakout rooms. You click that and then it gives you a list. And I think there's an arrow on the side of like room 2, and then there's an arrow and you click that arrow and then it gives you an option to join.
I don't see it. Let me see.
If
You
not,
know
I
what
think-
room that I need to join, Celeste?
okay. Can you
Yeah.
join room 3, please? Nathan,
go.
do you have a room?
I do not. Did
Oh.
you say? Yeah. Did you say room 3 for me or for Bond?
I think I said room 3 for Bon.
Oh, okay. For
Can you
sure.
also join room 3?
Yeah, for sure.
Yeah.
Is it the emoji sign? Area?
It looks like 4 cubes all in one.
I don't think I have a. I don't think I have. Oh wait, reactions. Oh no, just breakout rooms. Okay, I see it. All right, thank you.
Playing from desktop 93S9 LSN.
Hi, Elizabeth. Did you join late or
Yeah, I joined late.
Okay,
I
yeah.
already told Daniel, but
no, that's fine. So right now we're just breaking out into breakout rooms to start brainstorming.
mhm,
And
I
so
think I'm in purple.
okay, yeah.
I just saw.
Purple room 6. Wait, if you minds, can you hold off and just I just want to make sure the rooms are even because some people didn't show up. So
I gotcha. Okay, just put me wherever then.
1, 2, 3, 4, 5. 1, 2, 3, 7. Okay. Sorry, I'm not sure why I'm having.
You're good.
Okay, I'm gonna move into room 1.
Oh, that's fine.
And Kobe. And sorry. Oh, hey, what's up, Celeste?
Hi, I pretend I'm not here. Sorry, I'm trying to move to a different room.
No worries. Can you let me share screen?
Oh, you guys don't have access.
Yeah.
Drop the link in the chat.
Yeah.
All right.
Oh, Celeste, can you give us access to share screen, please?
Yeah,
Thank you.
that might take a while. anyone know how to do that?
When you go on share screen, there should be or I think it's in settings, or if you look at the bottom with share screen, there's like a little arrow. I think there's one that says let multiple people host or something.
I think only hosts. Who can share? Why is that option blanked out? Who can share screen? Are you guys able to share screen right now?
Yes.
You guys are?
Yeah,
I think
now we
so,
can.
yeah.
At least, but there we go. So we kind of just went through each requirement and kind of determined how many or which certain things we could consider to meet each requirement. So with ERU 1, we said, you know, you can use a parachute. We thought about like a hovercraft kind of like theory where you had fans or like turbine blades on the bottom to kind of slow down our descent. A deployable cushion, and then also aerodynamic stabilization. So it's kind of like active aero for you car people out there. That can just help us like stabilize stuff. And yeah, for ERU2, you know, how to put in the grappling hook, you know, that's just go to every time. For ERU2, we also did for, I think it was to talk about how we could go up that hill, 57.7% grade. So we said we needed to shield kind of the bottom of the vehicle and kind of each of the components, critical components, so that we would prevent damage from being in off-road conditions. We didn't enough power to go to the motors. Something we could do for traction is like chains from what we see in cars when you guys are on in snowy conditions. Cameras and sensors to avoid obstacles. Enough ground clearance to kind of also minimize how many rocks or other hazardous conditions we can experience in the environment. And also center of gravity. We also need to consider that so that when we're going up this hill, we're not gonna like flip or tip just because of how intense the hill is, basically. With ERUs 3, 4, and 5, we kind of all determined it led to a similar thing, which is cameras, sensors, communication, and a strong connection between GCS and also the GPS. Just and that kind of meets these three requirements. With ERU 6, I believe that kind of talked about the interacting with the hiker and transporting it. So we said we can use, you know, gurney-like principles, a hand or a claw mechanism, shovel mechanisms, and also for those of you who were here last year, the treadmill. So another thought one of our members had was that if they can walk, which I mean, in our case, we really don't assume we assume they're completely immobile, but if they can walk, we'd have supports around the vehicle for them to be able to interact. And then also for securing, one of our members came up with magnets. So yeah, that's kind of everything we came up with for each requirement. And then we really quickly drew up something in like a minute because the requirements are closing, but there's a shovel and there's like a very basic vehicle with a tiny little parachute there. So yeah, that's it.
Cool. Those were all really good ideas. I liked your drawing at the end to kind of express what you guys came up with. Yeah. And if there's no comments on group 1's design, I think we should go to group 2.
I like the picture.
Thank you.
So group 2, Jonathan, Sav, Victor. I think Cheyenne left.
Oh, that was us? I thought
Yeah.
it was group. I'm sorry. I thought we were group 5. All right. Anyway. Sorry about that. I'm going to go ahead and share we just did everything in the Google Doc. Let's see, screen 2. I was struggling with Bluetooth this morning. So basically, so we have a lot of the similar ideas as to what Corey just shared. Of course, a parachute is always a popular idea. It's the first thing that comes to mind when you talk about, or when you think about slowing a descent down. there was a little bit of thought given into the aftermath of having a parachute. So we have the option to, we could keep the parachute attached and then have it stow itself via a motor or something that'll wind it up. So, of course, we'll have to allocate sufficient space to store an improperly folded parachute on the vehicle. Or we can just detach an instant before it hits the ground. So that way the parachute's still inflated and then any breeze will catch it and then hopefully take it away from the vehicle. That solves the potentiality of it landing on top of us and getting tangled up in our actuators and motors. If we don't go with a parachute, we can do something shock absorbers, right? And one discussion we had in this line of thought was that we don't need traditional shocks, right? That are basically acting like a spring mass snapper. Springs store energy, which we specifically don't want. We want to dissipate energy. So we might be able to say, take shocks, modify them so there's no energy storage device on there and then attach them. But the problem is then that becomes what that bullet point says, unusable mass. Those shocks will then absorb one and only one shock. And then, they'll just be dead weight for the rest of the mission. And finally, we thought about some just kind of passive elements like squishy wheels, a rubber with a low durometer so that they could deform a lot on impact. That could help soften the landing on the rest of the vehicle as well. For the second requirement regarding going up the hill, of course, when you're talking about increasing traction, tank treads is something that always comes to mind. However, it was also mentioned that there was a reason that we might want to avoid that in the actual design. And in terms of the power requirement, we spoke of just getting sufficiently large motors to carry our mass up the hill at the required speed. One other thing that was noted is that because the speed up the hill is lower than the max speed everywhere else, this could be accomplished with a power transmission. And we came to a similar conclusion. The next 3 or so were more or less CS's problems, computer science problems. So our solutions mounted to basically mounting lots of sensors. So for the third requirement, that is video feed. So of course you need a camera. That kind of goes without saying. But of course we'll need to have a camera. We could do something like develop an app for it. And if we need some capability to look around, it could be attached onto a gimbal, right? So that would hopefully allow at least 2 degrees of freedom so we can look around in all relevant directions. And finally, the one thing that was brought up is if you want to achieve extremely low latency, you can use multiple networks to send the video feed. Okay, similarly for 4, obstacle avoidance. Sorry, not obstacle avoidance, GPS navigation. It's it's kind of, again, a computer science black box, but on our side, on the mechanical side, because a lot of us were that, we will need an array of sensors at very least, and proximity sensors could be something that's a viable option. Of course, to do GPS navigation, we'll need some sort of a GPS. And one novel idea was to actually take these, proximity sensors or whatever type of sensing element we're using and mount it on, just like we talked about with the camera, on a gimbal so that it could, look around and see something other than what's directly in front of the vehicle. Finally, for 5, this is obstacle avoidance. So of course, one of the obvious answers is to use the camera feed and put it through an object detection algorithm to determine what's around it. That's similar with the second point. For a unique sensing element used for this, we could use Lidar. That's something that's used in that. Is my voice coming through, by the way? I'm not muted, am I?
Yeah, we can hear you.
Okay, good. Sorry, that Zoom paranoia. Lidar is what's actually used on some actual autonomous vehicles. Actually, all autonomous vehicles have Lidar on them. And actually, they're going down in price. You can get one for a few $100 now for just hobby applications. And finally, in trying to get obstacle avoidance away from the computer science sides of things, we talked about just constructing the vehicle so that instead of avoiding obstacles around it, they could just go over it. So, without necessarily using tank treads. A tank is a good example, right? It doesn't have to worry about going around things. Most things it can go over or through. And finally, for 6, capable of moving an immobile stretcher. Naturally, we talked about, a mobile hiker. We talked about using a stretcher. Partially, I think because that was specifically outlined in the requirements last year. So, of course, that came up. For these, we had a couple of videos, which I'll just open up. Truth be told, I was fetching my dog for this part of the meeting, but it looks like this is an example of a stretcher that will, it's self-balancing. So that it looks like will be a method for keeping the hiker truly immobile, right, as it goes over bumps. So most likely there's just an accelerometer around here reading out angular position so that it'll correct the position of the stretcher. This looks like a retrieval method. We're not going to watch the whole 6 methods, but just a conveyor belt to help retrieve the hiker. I apologize. This was Cheyenne's idea, and I was gone when she described it, but it looks like an idea similar to what Corey called the treadmill, where we're using some moving belt to pick up the hiker. And that is a potentially gentle way to pick them up because if executed properly, you have a 0 velocity at the interface between the hiker and the belt. And finally, a medical stretcher. I think this was just done for demonstration. Oh, no, it wasn't. It's actually a novel idea. Okay, sorry. I said I was gone for this, but well, actually, this, if I'm remembering the idea correctly, this is actually an execution of what Corey was calling the treadmill. These belts are moving at the same velocity that this is moving forward, but in the opposite direction. So this guy, basically, he only sees a translation upwards. So there's no relative motion between him and the belts. That's why this was pursuable. And finally, for 7, the decision was made that 7 couldn't be completed, or actually it will be completed if all the previous requirements will be are satisfied. So the biggest thing we have to worry about for that are things like power requirements and the battery capacity to make sure that it can complete the mission properly. So it would be something like doing a power calculation and then, doing a factor safety, adding 30%, 50%. I remember Northrop had a specific recommendation about that, but I can't remember it off the top of my head. But I think that's it for what our discussion was. If my group thinks I missed anything, or if anybody has questions, we could address that now.
I don't think there's any questions. I think you did a pretty good way of describing everything. I like the idea for the gimbal on the camera, just so we can see more of a range, and also adding those videos. A good way to show what you're actually thinking. Sometimes words can get jumbled up, but having a video or a picture definitely shows what you're thinking, and there's not any confusion along that. But yeah, good job to group 2.
All right. You ready for the next one?
Yeah.
Okay, cool. So I'm Andres. I was in group 3. So Gabriel, if you want to share your screen.
Yeah.
All right. So for our landing mechanism for requirement 1, we were thinking of maybe, a few different ideas, like a parachute or like some sort of suspension or like a platform it can land on. But we kind of decided on a tether, so like retractable tether from the UAV. So the UAV would be flying, and then it would have like a winch on it with the tether, the cable all wound up, and it's attached to the UGV. And then when it gets closer or whatever, it starts lowering the UGV. And then when it gets closer to the ground, it slows down so it can drop it gently. And then we were thinking of maybe magnets that attach the winch to the UGV. Magnets that are strong enough to hold the UGV on there. But we have maybe a motor to apply shear force to separate the magnets. So like kind of slide them off of each other and then release the UGV onto the ground. And then the tether will just be retracted back up into the UAV and it could fly away. So that's what we were thinking for the landing mechanism. For the wheels, We were thinking of keeping a low center of gravity for when this is for requirement 2. So when it's going up a steep hill, it has to maintain low center of gravity so it doesn't flip over. We were thinking probably tires in the front, like really big, knobby tires, so it has grip, but treads in the back so that it has more surface area covered and it can keep pushing, especially up a hill. The idea of even having a wheelie bar on the back was thrown around just in case so it doesn't flip over if it's going up a steep hill or has a load on it. And so that's what we were thinking for the wheels. And then for requirement 6, this one was pretty fun. We were thinking of a bunch of different ideas. And do you guys know, remember those slap bracelets are like metal and you slap them on your wrist? So we were thinking something like that. So it'd be kind of like a stretcher. You got here on the drawing, there's the 2 blue things would be like those bands. And so we'd slide it under the hiker and then initiate those somehow so they would roll up and kind of wrap up the hiker inside this stretcher thing. We were thinking fabric, so it'd be kind of holding them in a bag. So that's what we were thinking. We're trying to determine whether it should be rigid or not, so it'd be more stable for the hiker in case they have a spinal injury. But we were thinking this thing could be lowered from the UGV and then slid under the hiker and then wrap them up and then towed back up onto the UGV with another winch and a cable. And then from there, on the back side of the bottom flap or something, there's a hook that can be connected to the other UAV that's going to come and take this away. So yeah, that's pretty much what we talked about. So if anyone has any questions or ideas or anything.
Last Search is really cool. I like the creativity for that one, and just goes to show you that you can find inspiration from literally anywhere. You said you found it from the slap bracelets, which 10 out of 10 was an awesome toy to have. Yeah, awesome job.
Thank you.
So if there's not any comments for group 3, we'll go ahead and move on to group 4.
Hi everyone. Sorry, I can't show my video because I have my screen disconnected from my computer and I was using that to draw. Let me share my screen real quick. Let's see. Oh, can you guys see my screen?
Yeah, we can see it.
Cool. So the format that we followed for a brainstorming wasn't so much on typing things out, rather just making a couple of drawings for different type of subsystems, such as a chassis, drivetrain, payload, and deployments. And so starting with ERU1, which was the vehicle shall be able to survive in flight route from a multi-role aircraft, we thought of a chassis component where we can have some type of external structure that has an egg shape. And the reason we want to have an egg shape is so that velocity can kind of decrease. And so when it impacts the floor, this egg shape can actually absorb some of the impact force. So then the actual UGV won't be as affected. Because if we compare that to, let's say, the UGV landing on the ground and there's no type of external structure protecting it, the UGV is going to experience the whole impact force, and there's more likelihood of components in the breaking down. For the drivetrain, we thought of maybe some type of spring system. So if the vehicle does land on the ground, the springs can absorb a lot of that energy. And so some of those components for the vehicle won't be as damaged. We thought of a parachute mechanism as well. Later on, eventually, we'll go more into the specifics on how we should design or select the parachute if we decide to go with that. But the parachute's just gonna lower the velocity, and so when it hits the ground, it won't hit it as hard. We also thought about some type of thrusters. Thrusters would be a little hard to make, but essentially with thrusters, again, you'll slow the vehicle down, and so you'll have a much easier landing. For ERU number 2, and this one was, it said the vehicle shall drive up a 57.7% grade hill at 3 miles per hour when fully loaded. We thought of some type of tracks, some threads, like you see on these construction machinery or on these tank vehicles, so they can make better contact with the ground and better traction. We considered some of the sizes of the batteries. Maybe larger batteries with better power output is going to make the vehicle be able to go up that hill at that velocity. Maybe a higher torque more as well. And another thing we had to consider too is we had to consider the center of gravity of the vehicle, because that can affect how the vehicle is able to go up, and that can perhaps also affect some of the power output requirements. We thought of some type of hook. It's not the best drawing, but it's a hook that maybe it can clamp onto the top of a hill that we're climbing up and just kind of drag us and push us upwards. A turbine as well, so the airflow can kind of push us up, and maybe some arms so it can attach to the ground and kind of just drag us up if we need to go up the hill. For ERU3, which says the vehicle shall have the capability of remote man operations through video feed. We didn't do so much drawings here, but we considered a mounting platform for the vehicle. And we know we have to have an antenna for transmission and an expandable antenna to increase the range as well. And some ultrasonic sensors for some of the range inputs. For ERU4, the vehicle shall be able to autonomously navigate to a specified GPS location. This one is more of software related, but I think we have to physically map some of the points, and we have to include some sensors so we can be able to meet that requirement. For ERU5, it's very similar to what we did for ERU3 and 4. So we just put a note to reference those two information that's listed. And for ERU number 6, this one said the vehicle shall be capable of preparing an immobile hiker for transportation. So we thought of a couple of ideas. We thought of some type of stretcher that's going to be able to lift the hiker up, and then some platform below where we can put the hiker down so he can rest easily. We thought of a forklift mechanism that's going to be able to lift the hiker, and some type of hooks on top that will bring the hiker towards the payload system of the vehicle. A claw as well that can just pretty much grab the hiker and place into the vehicle. And we thought of maybe driving over the vehicle, a vehicle that has high clearance, and just kind of scooping up the hiker and place it inside. And then finally, we thought about some rope mechanism where we can pretty much just attach a rope to the hiker in some way and just kind of bring them into the vehicle. For ERU7, we just referenced 6. We just weren't able to really go in depth on that one just because the time was up. But it was the same procedure as we did for ERU number 6. But yeah, that's all we have for all the ERUs. Does anybody have any comments or anything?
Can I hear more about the turbine idea that was above?
Yeah, let's see. Where did I put that? This right here.
Mm-hmm.
Yeah, so we talked briefly about that one. So the turbine idea, really, we just have some components at the rear of the vehicle, the side that's facing closer to the ground, and those components, whatever components we decide to go with, we just activate, and then at airflow would exert some thrust, and the vehicle would end up going upwards towards the top of the hill.
Okay, I see. So that's just to help with like a really steep hill then.
Yeah, and then of course, if we go more in depth on it, we'll notice that there's going to be some issues with turbine. But yeah, I mean, the turbine just component just exerts some thrust, and that vehicle is able to be pushed upwards, and so then you'll be able to increase the speed and reach the top of the hill.
Okay, I don't think I've ever heard that one before.
Yeah.
With the turbine, so that's very unique.
Yeah, just some unique design out there.
Mm-hmm. And actually, how about the Dutch? What's the one above that? You passed by it. I feel.
Sorry?
Yes, yeah, that one.
Yeah, so that was like a little Batman hook that we thought of. It's just a hook that would pretty much clamp onto a higher elevation on the hill, and would clamp on there, and then the vehicle would just be dragged up there. I don't know if you've seen from those Batman movies where they just exert these hook, and then it's it's the same way it operates. Yeah, so it's that hook would clamp to the top, and then the
Mhm.
would kind of be dragged and pushed upwards to the top of the hill.
I see. It reads Batman. I thought it was like Dutchman or something. I was like, oh, I've never heard of such a thing.
No, my
No.
handwriting.
No. I see it. It's not bad. right.
Does anybody else have any other thoughts?
I also agree that the turbine was a cool idea. I'm wondering now if there's a way to like combine the turbine and the thrusters, because they're both kind of like projecting air out in order for us to go a specific location. And if we could combine like both of those ideas in
Mhm.
order to meet the being able to land safely by going up the mountain, that would be really cool. So good job.
Cool, awesome. Thanks, everyone.
And I think that leads us to our final group, group 6. There was no group 5. Just letting you.
Hello there. All right. Let me just share what I got real quick. Where is it? Hold on. Things open. All right. So, hi, we're groups, or yeah, I'm gonna be repping group 6. So the first thing we had to do was analyze a solution for the in-flight drop. What we were thinking of is having like a suspension system along with attaching it to a balloon or like a mattress underneath the vehicle that would be like attached to the vehicle, so that when the vehicle is ejected out of the UAV, both the suspension system and the mattress would be enough to take the brunt of the force from falling the X distance. We were also thinking of using parachutes, wings, and someone was talking about it earlier, the egg design. I'm not sure which group that was, but we also thought of that as well. But it wasn't really egg shaped. We just thought of like a foam structure around the vehicle where it would protect the vehicle, and while it's falling, it would take the brunt of the force and just like brake on impact so that the vehicle can just ride on through. The two like big things that we were worried about with the parachute and the wings is that it might get like tangled on trees if we were to think this vehicle would be used in like a realistic situation. So we were kind of a little iffy on that. Moving on to the next solution, or the next problem that we had to solve, the 57.7% grade hill going at 3 miles per hour. To solve this, we need some form of movement, and we need to make sure that it's strong enough to go up the hill at 3 miles per hour. So we were thinking of doing a walking vehicle along with other methods of movement like tank treads with some motors attached to them, and just some regular wheels with some motors. We kind of finished this or analyzing everything early, so we started going into the pros and cons of each solution, and we realized that a walking vehicle would be very complicated, expensive, and it's more prone to be knocked over. So we were thinking more along the lines of either using tank treads or wheels with some motors attached. So we would have used like all-wheel drive, four-wheel drive, rear wheel. Those were like the benefits of the wheels and the motors. It's very customizable and easy to do. Tank treads, they're very grippy and have a lot of torque. So, but that sometimes it's hard to get over things depending on like how steep the object we're trying to get over is. So moving on to ERU 03, we need remote manned operation through video feed. we were sure that we needed a component that enables wireless communication. And we also figured that this is very heavily weighted on the people who do the coding and the software sides of things. So we need to make sure that our code's all good to go and make sure that we can do that communication. We're also thinking of something that lowers the lag between the signal and the command. So if we were to send out a command to the vehicle, it shouldn't take a lot of time for that command to activate or to receive information back from the vehicle. So at most, it would be like a second. Of course, we need a video camera because you can't do remote manned operation without a video camera. We also thought of adding a sensor to see if it's day or night, and lights or night vision on the camera if it's nighttime, so that we have an easier time seeing and doing manual operations if need be. We were also thinking of doing thermal imaging as well to help find the hiker. Moving on, we have the next problem. We have to autonomously navigate to a GPS location. So to solve this, we were thinking of doing autonomous algorithms and machine learning. Again, very code heavy, not my field of expertise, but I'm sure if we used those two things, we could get the job done. We also need a GPS module, and we were also thinking that a layout of the terrain coded into the vehicle would also be very beneficial for navigation. If that's not possible, we were also thinking of just getting a camera that would be able to sense out, like, if there's an object in front of it, then it would try to route around the camera. I believe we had something similar to this last year, but I forget the name. I think it was Intel Sense Real Camera or something like that. But for now, I just call it a sensing camera. Moving on, the next problem we had to face was avoiding obstacles. So again, the Intel RealSense camera would be very beneficial for that kind of objective, very good at avoiding objects. If the object is movable for, let's say, like wildlife, like a squirrel, or maybe it's like the hiker's dog, then we could have thermal imaging or a motion sensor camera or sensor to pick up on the wildlife activity so that we can navigate around the wildlife and make sure that we don't hit it. So we were also thinking of using sensors that detect how far the obstacle is, so that when we're like right in front of it, or we can gauge when we need to turn so that we don't hit the obstacle. We're also thinking of using sensors to avoid puddles, because if the vehicle isn't waterproof, then avoiding puddles is going to be mandatory. Otherwise, we just waterproof everything, which I feel is the better solution, because it could be raining and rain would just completely ruin our day if the vehicle is not waterproof. We were also thinking of adding bumpers to protect the vehicle if the vehicle ends up bumping into something, so that nothing gets damaged or destroyed while navigating. And we were also thinking of adding like arms or a dome on top of the vehicle, so that if the vehicle flips over, then it would be very simple for the vehicle to flip back onto its wheels. So if it flipped onto its side, then the arms would do its job and push it back onto the wheels. If it flipped over vertically, then the dome would just keep the momentum going and it would just flip back on its wheels. Moving on, the next problem we had to deal with was prepping the immobile hiker for transportation. So one of the ideas that we had was getting a smaller vehicle that would be stored inside the bigger vehicle, and using that smaller vehicle to transport the hiker onto the bigger vehicle. And this would be done via like a ramp. So the small vehicle would come out of the bigger vehicle, go down this ramp, latch onto the hiker, and then pull the hiker back into the bigger vehicle. Another thing we were thinking of was using a basket. So there would be an arm attached to it, and then you'd use the arm to like scoop up the hiker. The third idea that we were having is kind of like a stretcher situation. So there'd be two arms, which would be attached to cables per se, and these cables would like go under the hiker, and they would kind of like separate, and in the middle would be like a stretcher kind of situation, kind of like a net, and they'd lift the hiker up, and we could then place the hiker in a more secure spot, or we could have it like enclosed to make like a capsule for the hiker. And our last idea for like securing the hiker was there would be a ramp that would come out of the vehicle, and there would be arms attached to this ramp. And it's kind of similar to what we had here, but these arms would lift the hiker via like a stretcher and then place it back on the ramp. And then the ramp would pull in the hiker, and then the ramp would go back inside the vehicle, and the hiker would be secured inside the vehicle. Moving on, the seventh problem that we have to deal with is moving the hiker 1,500 feet from its current location. So we were thinking of just using solar power to power the batteries. That was one of our ideas, and we also needed to make sure that the vehicle would be able to carry the load of the person, and that the motors would be able to handle the person and the vehicle. And we had some extra time in, so we also decided to figure out some solutions towards the design problems for the vehicle, which was the electronics tray. So all of our electronics need to be on a removable tray. So we basically need just a tray and the electronics that need to go onto the tray. And we'd have like an ejection system similar to a DVD player or like a drawer in your house that's very easy to remove. And yeah, those were all of our ideas for the vehicle. Does anybody have any questions, thoughts, concerns?
I think, sorry, all of these ideas were pretty cool. I like they reminded me of the rushing nesting doll when you said like the little robot out of the big robot. And I also like your accuracy towards realism of just like for wildlife, and like maybe the hiker did have a dog. That's something to take into consideration. And so all these like if statements and making sure like you cover a full range of the possibilities. That's really good. So yeah.
I also like the fact that you guys take into consideration if the vehicle happens to flip. I feel like it's one of the few times I've ever heard about that being applied to the vehicle. But yeah, that'd be great, because I do know that there are some requirements when it comes to presenting to Northrop, that if something does go wrong, the amount of time we have to fix it is limited to very few minutes. So if we had something like that, that would make it so that the vehicle's not a failure if it does happen to flip. So yeah, I like that addition.
Thank you. Thank you.
So if no one else has any questions or comments that they would like to share, I think that was the last presentation, and I just would like to wrap it up a little bit before we end for lunch. So I think all of you guys came up with really good ideas on brainstorming in order to fill the requirements. And all of you guys were in a group of like 8 people, and we already got a good range of ideas that would be feasible to progress with. And just once we do get the actual RFP, all of us will be thinking about it together, which are more heads, more ideas, and hopefully, and we'll be able to come up with a pretty good vehicle towards the end. So I really look forward to that. I hope you guys enjoyed the brainstorming workshop. And after we come back for lunch at 1 p.m., the project manager, Lizette, has orchestrated a workshop for deriving requirements. You guys already have seen the requirements that we've dealt with last year, so it kind of gives you a vague idea of what we're going to be looking at. And yeah, we'll take it. That workshop will be led by Daniel, a previous member on, I think, systems, which mostly deals with deriving requirements. So that would be a really good workshop for you guys to attend at 1 p.m. And I will drop the Zoom link after this meeting because it's a different Zoom link. But with that, if there's not any questions or comments, I'll end the recording and I'll let you guys go for lunch or yeah.
Thank you. Thank you.
Bye, guys.
Yeah.
Celeste, I might have to leave early if I go to that workshop. Is that all right?
That's perfectly fine. It will
Okay,
be
thanks.
recorded as well. So yeah.
Okay, thanks. I just wanted to ask. Okay, I'll see you all soon.